everybody. I'm Dr. G, and welcome to Science Time with Dr. G. We're gonna sing a song about motion. If I was drifting in outer space, no gravity keeping me in place, well, I would move at a constant pace. I'd be in motion. I'd be in motion. But if I was acted on by a force, it would change my speed and alter my course. And I would do the same to it in reverse. I'd be in motion. I'd be in motion. We are in motion. Standing on a planet that's in motion. Moving round a star that's in motion. We're part of a galaxy in motion. We are in motion. And if you're moving to the left or moving to the right, if you're sleeping in your bed or if you're dancing all night, we are in motion. We're part of a universe in motion. We are in motion. Hey! Or let's get deeper into it. So, if you knew my trajectory, that's my path, and you could measure my velocity, well, that's my speed, you could calculate just where I would be. I'd be in motion. I'd be in motion. Motion is changing position over time. If I'm going fast, my velocity is high, but if it looks like I am standing still to your eye, I'd be in motion. I'd still be in motion. We are in motion. Standing on a planet that's in motion. Moving round a star that's in motion. We're part of a galaxy in motion. We are in motion. And if you're moving to the left or moving to the right, if you're sleeping in your bed or if you're dancing all night, we are in motion. We're part of a universe in motion. We are in motion. Hey! Alright, so, let's get Newtonian. First law. A body in motion will tend to stay in motion. A body at rest will tend to stay at rest. Second force is equal to the mass of a body multiplied by the acceleration of the body. If a body exerts a force on another body, the other body exerts the same force in the opposite direction. We are in motion. Standing on a planet that's in motion. Moving round a star that's in motion. We're part of a galaxy in motion. We are in motion. And if you're moving to the left or moving to the right, if you're sleeping in your bed or if you're dancing all night, we are in motion. We're part of a universe in motion. We are in motion. Hi there! As I mentioned, I'm Dr. G, and this is Science Time with Dr. G. Now, I'd like you to imagine something for me. Imagine being an ancient human, looking up into the night sky and seeing a vast starscape, unclouded by modern city lights. What are those things? Luckily, we know. So, in the early universe, shortly after the Big Bang, matter was fairly evenly distributed throughout the universe. I'm talking about mainly hydrogen, the most basic of all elements. Now, over time, gravity caused the hydrogen to form together into clumps. And as the clumps got bigger, they got hotter, until they got so hot that the hydrogen fused together to form helium. Now that is a nuclear fusion reaction which releases energy. And that's essentially what a star is, an ongoing nuclear reaction held in place by its own gravity. Now, over time, the star might start producing heavier elements like carbon and oxygen. stellar wind can disperse these elements out of the star and throughout the universe, with some of them potentially even ending up in our own bodies. We are the stuff of stars. That's one of the things we're going to talk about in this next song. This is called What Are Stars? Play a little theremin for you. So, when you look up into the sky at night, what do you see? Astrophysical phenomena vast distances away. It's a panorama of lights that has fascinated us for millennia, not to mention the fairly ordinary star we see each day, that's the sun. Our galaxy is a system of hundreds of billions of stars. Many are binaries and stellar clusters bound by gravity. There are dwarfs and giants, quasars, pulsars, neutron stars, and more. So join me as we journey to unlock this mystery. What are stars? What are stars? What are stars? Where are those voices coming from? What are stars? What are stars? So, in areas of space with denser matter, such as nebulae, gravity causes clumps of mostly hydrogen to form. The temperature will begin to rise as the cluster's mass increases until nuclear fusion starts, and you could say a star is born. Now, the remaining matter in a stellar cloud can collect to form objects, like the planets in our solar system, orbiting the sun. Stellar wind disperses particles through a stellar system and beyond, which means the stuff of distant stars can be found in everyone. What are stars? What are stars? What are stars? What are stars? I want to know. Now, when a star exhausts the supply of hydrogen at its core, what happens next? Well, the answer will depend upon its mass. The outer layers of the star will expand and start to cool. The mass decline and gravity will cause our star's collapse. So in 5 billion years, a very long time, our sun will expand as a red giant, then contract until it settles as a white dwarf, dim and small. A larger star would erupt in a brilliant supernova. And larger still, it would collapse into a black hole. What are stars? What are stars? I want to know. What are stars? What are stars? Well, I think we have some idea now. What are stars? Nuclear furnaces converting hydrogen to helium, creating atoms, radiation, heat, and light. Spheres of superheated plasma held by gravity, generating photons that make them shine so bright. We see them every night. What are stars? Every night, that is, except when it's cloudy. The stars, of course, are still there, but we just can't see them because of the clouds. Funny stuff. All right, question for you. What is the closest star to the Earth? I'll give you a hint. It might have shined on you today. That's right, it's the sun. Now, the sun is a fairly ordinary sized star, but it's still really, 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 really big. It's so big that it has a whole bunch of objects caught in its gravity orbiting around it. These include asteroids, comets, the icy bodies of the Oort cloud and Kuiper belt, and of course, the planets. And this next song is called Solar System Song, and it's going to take us on a journey through the 8 planets. So these songs are actually all original songs. They're all available online. I'll send the chat later. Send a link in the chat. I recorded them with my friends. I wrote all of them myself. So, the planet Mercury, the closest to the sun, the smallest planet in our system, it is number 1. It's got a rocky surface, almost no atmosphere. One day on Mercury would take 2 Mercurian years. The planet Venus, the brightest in our sky, the closest to the Earth in distance and in mass and size. A heavy atmosphere that keeps the heat inside. The surface gets so hot that even lead is liquefied. Next one might be a bit more familiar. You know the planet Earth? It's where the humans dwell, a molten mantle with a water-covered rocky shell. The Earth is not too cold, and it is not too hot. We better keep it that way if we are to have a shot. The planet Mars. It's got 2 tiny moons. The reddish color comes from iron in the sandy dunes. It's half the size of Earth. It's got some polar ice. We sent some robots, but so far there is no sign of life. These are the planets of the solar system, and in this song we will describe and list them, passing along the planetary wisdom. Na 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 na. These are the planets of the solar system, and in this song we will describe and list them, passing along the planetary wisdom. Na 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 na. All right, we're moving beyond the asteroid belt to the gas giants. The planet Jupiter. With its enormous size, it's more than twice as massive as the others all combined. A giant ball of gas around a solid core with nearly 80 moons we know of, but there could be more. The planet Saturn. With all its pretty rings, they're made of particles of water, ice, and other things. 2 of its largest moons have oceans underground. It's the conditions where we might expect that life is found. These are the planets of the solar system, and in this song we will describe and list them, passing along the planetary wisdom. Na 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 na. These are the planets of the solar system, and in this song we will describe and list them, passing along the planetary wisdom. Na 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 na. Uranus. It's got a funny name. It's blue like Neptune, but the planets are not quite the same. It rotates on its side. Its rings are vertical. It's mostly icy water, methane, and ammonia. The planet Neptune. Too far away to see. Smaller than Uranus, but greater mass and density. Near supersonic winds, anticyclonic storms. Out near the Kuiper Belt is where you'll find this icy orb. These are the planets of the solar system, and in this song we will describe and list them, passing along the planetary wisdom. Na 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 na. These are the planets of the solar system, and in the song we will describe and list them, passing along the planetary wisdom. Na 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 na. And of course there are a number of other dwarf planets like Pluto, Ceres, Eris, and Makemake, which I just didn't have time to talk about in this song, except for now, I guess. Because these are the planets of the solar system, and in this song we will describe and list them, passing along the planetary wisdom. Na 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 na. That was Solar System song. Did you hear your favorite planet in there? Mine is the Earth. It's the obvious choice. I also think Neptune's pretty cool. Anyway, something I mentioned earlier, I want to talk a little bit more about. Gravity. Gravity is something that we experience all the time, every day. In fact, our lives wouldn't be possible without it. Or at least, things would be pretty different if every time you took a step, you were propelled in one direction until you bumped into something. But what is gravity? Well, Isaac Newton defined it as a force by which an object with mass pulls other objects toward it, according to a predictable equation. But what is this force? And why is it so different from every other force we know about, like electromagnetism, which we will talk more about later? Albert Einstein proposed that gravity is not a force at all, but the result of the curvature of space-time caused by mass. Now, to visualize that, think of something heavier than an apple, maybe like a bowling ball. Imagine setting a bowling ball on a mattress. The mattress would bend around it. In a similar way, massive objects cause space-time itself to bend around them. Now, all objects with mass do this, but it's only the biggest ones, like the Earth or the Sun, where we actually notice it. And that means that when I drop an object, it follows the straightest path available to it based on the curvature of space-time. Gravity is pretty wild, and we're going to talk a little bit more about it in this next song. This is called Gotta Be Gravity. And I'd like to request your help here. I'd like to request that you snap your fingers along. I may not be able to hear you, but I think it helps anyway. And if you can't snap your fingers, you can clap your hands. I don't think I could make any sound snapping my fingers until I was about 20. Now I'll get you to keep doing that because I have to sing and play the theremin. And I need my hands and I need to concentrate. Keep it going. If I were to drop 2 objects from my hands, one heavy and one light, which would be the first to land? If you said the same time, then I think you understand. But what could it be? What could it be? It's gotta be gravity. Gravity is the property that causes objects to attract, with the strength of the pull in proportion to the mass. And the distance between them squared, it's inversely proportional to that. And what could it be? What could it be? It's gotta be gravity. If you were in a rocket, accelerating at a certain rate, you couldn't tell if it was gravity in a stationary state. Hey! It's gotta be gravity. Objects are pulling me. I'm pulling them microscopically. What? It's gotta be gravity. It's gotta be gravity. Forming the galaxies, shaping their trajectories. What? It's gotta be gravity. Alright, so for this part, you can pull things towards you. You can pretend you're gravity. It's a lot of fun. It's gotta be gravity. Whoa, 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 whoa. It's gotta be gravity. So the story goes, the apple fell on Newton's head. And then Albert Einstein changed the paradigm again. Found that gravitation results from space-time being bent. They're asking, what could it be? What could it be? It's gotta be gravity. So what if instead of being linear, space and time are curved, so that very massive objects like the sun or the earth bend space-time itself, enough that straight lines seem to swerve? And what could it be? What could it be? It's gotta be gravity. So here's an analogy to help to explain. Picture a bowling ball resting on a 4-dimensional plane. What? It's gotta be gravity. Objects are pulling me. I'm pulling them microscopically. What? It's gotta be gravity. It's gotta be gravity. Forming the galaxies, shaping their trajectories. What? It's gotta be gravity. Whoa, 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 whoa. It's gotta be gravity. You're still with me? Alright, let's get back to snapping our fingers, clapping your hands, whatever you like. And we're going to talk a little bit more about gravity. So, it's gotta be gravity. Objects are pulling me. I'm pulling them microscopically. What? It's gotta be gravity. It's gotta be gravity. Forming the galaxies, shaping their trajectories. What? It's gotta be gravity. It's gotta be gravity. Objects are pulling me. I'm pulling them microscopically. What? It's gotta be gravity. It's gotta be gravity. Forming the galaxies, shaping their trajectories. It's gotta be gravity. It's gotta be gravity. Objects are pulling me. I'm pulling them microscopically. It's gotta be gravity. To drop 2 objects from my hands, well, they would move as the curvature of space-time demands. It's a curious phenomenon that we don't fully understand. And what could it be? What could it be? It's gotta be gravity. It's a good apple. All right, so I suppose I should talk a little bit about this instrument here. So this is a theremin. It was invented just over 100 years ago by the inventor Lev Theremin, or Leon Theremin, as he was known in the West. This theremin itself is not 100 years old. I just got it. It's a Clairvox Centennial, and in fact it's named after Clara Rockmore, the greatest player of the instrument ever to have lived. Look her up on YouTube if you want to hear some really good music. Anyway, playing the theremin may seem like magically conjuring spooky sounds out of thin air. But it's not magic, it's science! And the way it works is this. So when I turn the theremin on, this antenna becomes charged. Let's say with a positive charge. Now that generates an electromagnetic field around the theremin, which produces a negative charge in my hand. Kind of like two poles of a magnet attracting. Now inside the theremin is a circuit called an oscillator that causes the charge of the antenna to alternate between positive and negative at a really fast speed. I'm talking hundreds of thousands of times per second. And the rate of change is controlled by the position of an object relative to the antenna, like my hand, or pretty much anything else. It's a very finicky instrument, and I think it also has the distinction of being the only instrument that you play without touching it. Anyway, inside the theremin is a second oscillator operating at a similar but constant frequency. The two waveforms cancel each other out, leaving a much longer waveform, just like a sound wave. And when I run it through my amp, spooky sounds! The sounds of science. The sounds of electromagnetism. Which, coincidentally, is the name of the next song. Science, 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 science. We know all matter's made of atoms, but what holds them together? What binds the molecules in objects and makes them feel solid? And what gives everything around us all the different colors? Let's go on a journey of electromagnetic knowledge. Electromagnetism. Think about this fact. Particles with the same charge will repel. With the opposite charge, they'll attract. Electromagnetism. Electromagnetism. Electromagnetism seems like magic, but it's science. Positive and negative attraction. It's a fundamental interaction. Studying the universe in action using science. Just like the sun's gravity keeps the planets in motion, 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 motion. Inside an atom, the protons pull the electrons in the shell. But unlike gravity, which only ever holds things together, particles with opposite charge will attract, but with the same charge they will repel. Electromagnetism. Electromagnetism. Electromagnetism seems like magic, but it's science. Positive and negative attraction. It's a fundamental interaction. Studying the universe in action. Using science, science, science. vibration. We call it light or gamma rays, or maybe radio waves, based on the frequency of oscillation. Science, electromagnetism. Electromagnetism seems like magic, but it's science. One more time. Electromagnetism. Electromagnetism seems like magic, but it's science. Positive and negative attraction. It's a fundamental interaction, studying the universe in action using science. Thank you. Electromagnetism. Now, I just want to take this opportunity to say thanks to the library for having me. Thanks to all of you for coming out and sticking around. And yeah, this is actually my first Dr. G show in almost 2 years. Part of that, of course, is because of the pandemic. But also, during that time, I became a dad. And, well, it's really made me realize it's not easy to be a kid during the pandemic. It's not easy to be a parent during the pandemic either. But hey, we're here now, and that's good. One of the things I found most fascinating about having a little baby was thinking about all the scientific processes that allow her to see, and hear, and eat, and grow, and learn, and love. Because we are actually made of the same building blocks as everything else in the universe, the same basic elements. But still, every one of us is special. It reminds me of the Carl Sagan quote, "We are a way for the universe to know itself." And that's the inspiration behind this next song. This is called Matter. So this is a lullaby I wrote for my little girl. And, well, it got her to sleep a few times, so I guess it worked. When you are brand new, your eyes are wide, each day you're growing. Your cells divide, metabolizing the energy. You're made of matter and you matter to me. I'll try to teach you what you need to know, give you the care that you need to grow. You're growing every day. It's fascinating to see you're made of matter and you matter to me. Sometimes you may be sad or lonely. Some days you laugh and some days you cry. But even in the hardest moments, it's wonderful that you're alive. And when the sun shines, you run and play. Or in the night time after a busy day, you are a marvel of biology. You're made of matter, and you matter to me. As you get older, you continue to change. Each day the world seems a little less strange. I hope you're always fascinated by the mystery. You're made of matter and you matter to me. I'll give you food you may not always like, give you guidance. I may not always be right. I'll give you love times infinity. You're made of matter and you matter to me. Sometimes you may be sad or lonely. Some days you laugh and some days you cry. But even in the hardest moments, it's wonderful that you're alive. And when the sun shines, you run and play. Or in the night busy day. You are a marvel of chemistry. You're made of matter and you matter to me. 'Cause even in the hardest moments, it's wonderful to be alive. And if the sun shines, you run and play, or in the nighttime after a busy day, I hope you're always fascinated by the mystery, 'cause it's a marvel just to be a human being. You're made of matter and you matter to me. Thank you. So, that was Matter. And yeah, all of these songs, I wrote all these songs, I recorded them with my friends, and they're all available online. I'll send the chat right now. There you go. You can find my music there. You can search for it on Spotify or Apple Music. It's a bit hard to search for just Dr. G. I chose a very unsearchable stage name. Whoops. But if you search Dr. G Goes to Space, that's my first album, you can find it, or Dr. G Physics, my new EP. Anyway, we've reached the end of our journey across time and space, just about. But I don't think I can leave you without talking a little bit about aliens. Now, scientists have so far discovered no evidence that life exists outside the Earth, that extraterrestrial life exists. But what we do know is that there are billions of planets out there within a habitable zone from their stars. That means it's not so close that it's too hot, and not so far away that it's too cold. So with all those planets out there, especially considering how old the universe is, you would think that the processes by which life formed on Earth would be likely to have happened on at least one other planet, even if the odds are really slim. Which leads to the question, where is everybody? And that question has a name, and that name is the Fermi Paradox, which is the name of this next song as well, the last song that I'll leave you with. So once again, I would like to thank the library for having me. I would like to thank all of you for sticking around. And yeah, I'm Dr. G, and this has been Science Time with Dr. G. And so for this next song, maybe we can clap our hands again if you feel like it. You can even sing along if you want. The lyrics are pretty simple once we get to the chorus. You'll know it when we get to it. But first, let's talk a little bit about aliens. If there are hundreds of billions of stars in our galaxy alone, with potentially billions of planets in their habitable zones, then even with 1,000,000 to 1 odds of intelligent life, statistically speaking, we're probably not alone. But I've never seen an alien. Have you? So, assuming for the moment that our hypothesis is true, then, as physicist Enrico Fermi once asked, where is everybody? And I pose the question to you. Hey! Where is everybody? Where is everybody? Where is everybody? It's the Fermi Paradox, the Fermi Paradox. Where is everybody? Where is everybody? Where is everybody? It's the Fermi Paradox, the Fermi Paradox. Imagine a planet formed 5.5 billion years ago, where compared to ours, life had a billion-year head start to grow. Well, if you can fly across the galaxy in just 1,000,000 years, which you can, the question is, why haven't we seen them before? Or imagine a civilization 1,000,000 years older than ours. Imagine a super intelligent people who can travel the stars. Well, just as we send radio signals out into space, you would think that evidence of those beings could be seen from afar. And so I ask, where is everybody? Where is everybody? And where is everybody? It's the Fermi Paradox, the Fermi Paradox. Where is everybody? Where is everybody? Where is everybody? It's the Fermi Paradox, the Fermi Paradox. Let's consider, maybe life will inevitably come to an end. Or maybe they communicate in a form that we can't comprehend. Or maybe they exist in a form that we can't perceive. Maybe they live in an environment that they don't ever need to leave. Or maybe the Earth is in a lonely backwater of space. Maybe they just don't have any interest in this primitive place. Or maybe, well, maybe we just need a little bit more time. Well, it's a humbling thing to look up into the sky at the tiny fraction of the universe that's visible to our eye. Whether life is all around us or so rare that we're alone, it's truly remarkable that we can even ask why. So be good to each other, because we are a single human race with the intelligence to understand the many challenges that we face. And if we all work together, well, we can reach for the stars and uncover the mysteries that await us out in space and find out. All right, so for this next part, I'm going to need your help singing along. You've probably figured out the lyrics by now. They just go like this. Hey, where is everybody? You want to try it? Let's do it again. Where is everybody? All right, let's keep it going and I'll bring it back in one more time. Hey, where is everybody? Where is everybody? Where is everybody? It's the Fermi Paradox, the Fermi Paradox. Where is everybody? Where is everybody? Where is everybody? It's the Fermi Paradox, the Fermi Paradox. Where is everybody? Where is everybody? Where is everybody? It's the Fermi Paradox, the Fermi Paradox. Where is everybody? Thank you very much. I am Dr. G, and this has been Science Time with Dr. G. I hope you have a great day.